Welcome to Scott++. In a previous video, I mentioned wanting to do some refactoring to the star voting web app. So today we're going to look at what I refactored and the reasoning behind it. We'll look at leaning into explicit rather than implicit code, making atomic transactions, and why not to build an event-driven system. All that after the intro. So a quick review, we're building a web app that lets organizations run an election using star voting, which people are telling me is the best voting method for people to vote in alignment with their values. That is, it's the voting method that chooses the candidate that best reflects people's preferences. So this is a full stack web app, but for now we're just focused on the back end. It's in Node.js using Express and TypeScript, though there is still some JavaScript hanging around here and there. Also, before I forget, it is not just me working on this project, so a huge thank you to Mike, Arend, and everyone on the star voting dev team for really driving this project forward and letting me tag along. One last thing, I'll try to structure the video by first presenting the problems I saw and then how I tried to go about solving them. And I'll try to give opportunity for you to pause in between and think about how you might solve those same issues before being biased by my own solution. Obviously, I'm making this channel for entirely selfish reasons, and one of those includes the opportunity for me to grow from you as engineers. So if you saw a better or different solution to some of these issues, please don't be shy, leave a comment. All right, without further ado. So the first thing I want to take a look at are our route handlers. So as in the previous video, I was writing all the testing, I was working with our routes, which basically take the request and decide how to handle them and send the response to the client. So before I made any changes, this is what our route handler looked like specifically for the cast vote election. I'm just going to take a look at this particular route, but this is kind of endemic of the entire app at the moment. So in the cast vote route, we have a number of handlers that come through here, and each of these are Express middleware. So they all take a request object, the response object, and potentially a next function callback, which effectively just calls the next function in this stack. So for me, this was a little obtuse and it was difficult to follow. I needed to jump between these four functions, which are all in different files, to really figure out what's going on. If we take a look, for example, at this submit ballot controller, we see that it's grabbing a number of things from the request object itself, such as the input ballot that the user submits. And then later on, it's saving more data into that request object. Here it's adding an election roll entry, a updated ballot, etc. And then in this update election roll controller, it's going to add some more information into that request object. And then finally here, it returns a response to the client. So for me, this was all just a bit confusing. Again, the logic spread out kind of in different places. And inside any of these functions, you kind of have to take for granted what information might have been passed down into that request object. So that's the problem. And now let me load up how I refactored this controller. Now's your chance to pause. So here's my refactor version. It's just this one cast vote controller. So it's a single function and it takes the entire flow of this handler from beginning to end, all the logic contained within this one function. Obviously it needs to take data from the request, but it does so, I hope, very explicitly what it's doing. And it doesn't then try to store additional data back in the request. It just grabs that data and then it's used later on in the same function. A quick run through what it's doing. First, we grab the user, the ballot, we do some validation. We grab the election that the user is trying to vote in from the database. We extract some more information from the request. So then we eventually save the ballot, and then we also generate and save the voter roll. The voter roll is kind of like the voter registration, and these are separate because for an election, we may have election reviewers who maybe look through everyone that voted and verify that they are indeed eligible voters. and we don't necessarily want to show them how that person voted, just that they did vote and that their ballot was counted. So these are actually stored separately. One is the ballot itself, and one is what we're calling the voter roll. And then finally, at the end, we return the user's ballot. So that's the whole flow, beginning to end, one function. Obviously, there are little helper functions that are used here, but they just take in what they need, and then they're very explicit about what they're returning. They're not stashing anything inside the request object. So for me, that seems a lot clearer and easier to follow as a developer. Would love to hear what you think, especially if you disagree. But now that this is more clear, what is the next biggest problem with this function? Because we are not done yet. So I'll give you opportunity to pause and think about it, even though I already spoiled it in the intro. These transactions are not atomic. And what do I mean by that? An atomic transaction is basically something that's either going to entirely succeed or entirely fail. Right now we're making two separate calls to the database in two separate tables. We're doing the submit ballot, and then we're also doing this update the election roll. But theoretically, after we save the user's ballot, the server could crash, right? Before it has a chance to save the election roll. And then we would have a ballot without the registration data of who cast that ballot. And that would be awful, especially for an election. So we cannot let ourselves get into this situation. Now, there are a few ways to go about solving this. Again, maybe think about it for yourself before I go on. So one way to handle this atomically, depending on which database you're using, if your database supports atomic transactions. We're using Postgres, and in this case it does. Basically, you can combine multiple writes to your database into a single PostgreSQL statement. If you start with this begin and then end with a commit, that entire thing is either going to succeed or it will fail. You can also get fancy with this and do conditions inside of this transaction. So that's probably the simplest way. Another way to go about this is to use event-driven architecture. And what do I mean by this? Basically, you would have a request handler that writes every event coming into your system to an event store. So in this case, we would write that this voter has cast this ballot into an event store, which is effectively a log of all the events that have come through the system. Then separately, a ballot handler would pick that up and maybe update the ballot store, and the roll handler would pick that up and update the roll store. And depending on your architecture, you might not even need additional persistent storage for your different types of data, because everything can be reconstructed from the event log if necessary. Obviously, you would at least want something hanging out in memory to make calculations faster. But in something like this, even let's say after you write the event, if either the ballot handler or the roll handler go down, these could be running on the same server, theoretically on different servers. Once those servers start back up, they're just going to grab whatever events they had missed and hadn't processed yet from the store, and they're going to get right back to where they need to be. Now, this does add some extra complexity in terms of orchestrating these events and maintaining consistency, right? Because you will have times when the ballot handler finishes before the roll handler or vice versa. So when you are, for example, checking that someone hasn't already voted in the selection, you need to make sure whatever data you're consulting has the most up-to-date information. And obviously what we see here is actually, three different writes as opposed to a single write. So there is a little more complexity involved in a system like this, especially if your team is not used to working in this type of style. This is the structure that I was using with TagShare, and it's a structure I generally would recommend for a lot of projects. However, it is a little more complicated. So in the case of star voting, maybe taking on that extra complexity isn't the highest priority right now, especially when the atomic transactions that we need to make are relatively simple and straightforward. So in this particular case, what I did to make this transaction atomic, so I moved all the logic of saving the data to the database down into this persist ballot to store function, and I effectively created a separate cast vote store, which just wraps a single SQL statement, just like I showed here, where we have a begin. It updates both the ballots table and the roll table, and then does the commit. Now there is extra complexity here, right? Obviously, this introduces more coupling, and one of the huge advantages of the event-driven architecture is everything is very decoupled. While dealing with this coupling here, I tried to keep it as minimal as possible. The cast vote store only handles the particular functions that require both of these database tables at the same time. If we get to a situation where we start seeing more and more coupling of our data, if we need one transaction that operates on both the votes and the users, and this one on the users and the roles and whatnot, and it starts to become spaghetti, at that point it may make sense to move to an event-driven architecture. But right now, as long as it's just minimal, I'm leaning on simplicity, and not refactoring the entire code base to be event-driven is definitely simpler than the alternative. So that's all I was able to get done in the past couple of weeks. Quick recap, leaning towards explicit functions and logic. If you can get the entire flow of an action in your system all into one function, that makes it much easier to follow. Ensuring that your transactions are atomic when they need to be, and do consider event-driven architecture, but don't discount the value of simplicity and the cost of extra complications. All right, I hope this video has been useful to you. They say you learn best when trying to teach, so thank you again for giving me the opportunity to try that. Thank you for watching, and I hope to see you in the next video.